right, so let's see. Let's begin. Let's begin. Who's our first randomly selected student from our popsicle sticks, Daniel? Caesar. Caesar, congratulations. First, I want to say, behalf of the staff here at Jordan High School, and of course, myself. Tell me, what's happening with that pink fluid?
It's increasing, no, it's decreasing.
Ooh, increasing? Is it increasing and decreasing? Okay, so decreasing how? Like what? We'll say it's increasing and decreasing. Okay, I'll put that. Let's get. Who's another person? So thank you, Caesar, for your excellent input on this kind of random question. Can you give me another person? And then I'll get to you, Jason.
Rico.
Who? Rico. Rico. So what do you put down for this pink solution? This pink fluid. What's happening with this? From A to B, what do you see? Okay, so you're agreeing with your classmate, your colleague about it, but you think it's decreasing too or just increasing? It's doing both. Okay, just like, so you're just agreeing with your colleague. All right, all right. Jason, what would you like to add? It's what? Closer to each other. The pink stuff is getting closer. It's trying to all come together. Where is it all trying to come together? On the right side. So we see on the A side, it's equal on each side of the jar. On the B side, it's all kind of coming together on the right side. Okay, so it's all coming together. Okay, all right, I like that. Okay, kind of coming together. Okay, all right. Well, let's move on from our pink fluid because we're just writing down our ideas. So that's the pink fluid. Let's move on to the purple dots. Daniel, can you give me another name? Give us another name because we're in this together, Leonardo. Right? All right. Steven. What did you put for these purple dots? What's going on with these?
They get more spread out when like the fluid moves more to the right.
Okay, more. So they're kind of all stuck in this amount of area, right? And they get a lot more area to move around as they get spread out. So good. So I see that too. Do other people see that? Jacob, do you see that? They get more spread out? So more spread out in jar B. Okay? All right. Now I'm going to ask another name, and I want you to focus on, we haven't really talked about, there's something in between the jar, right, in the middle. What is this thing in the middle? It has a name. What is it? It's a, Leonardo, can you read that for me?
What?
Yeah, can you read this? What is this in the middle?
I don't know.
Can you sound this out for me?
Semi-permeable.
Semi-permeable, I like it. That's a good job. A semi-permeable what?
Membrane.
Membrane. Yeah, we talked about membranes, cell membrane. You heard about it. The organelles are made out of membrane. So I want you to focus on the membrane. What do you see with this membrane and the purple dots? Daniel, give me one more name. Jeremy. So what do you notice? Focus on these dots and the membrane. Look at the dots here on each side versus the dots over on the B side. What? You notice anything? There's more dots over on the right side, on the B side than A. Well, let's count them. Can we count them? Let's see. 1, 2, 3, 4, 5. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So it looks like we have 28 dots. Can somebody count the dots on the other side? Count them up with your eyeballs. Might not be as easy without the little pen. Are there about 28 on that? Ooh, I counted 28. So there's the same number. What about on the left side? How many do we got? 7. How many over here? 7. Ooh. So what can we say about the number of dots? Stay the same. So number of dots are the same. So what does that mean? Is this permeable to the fluid? Can the fluid go through our barrier? Well, did we see the fluid move to the side? We did. The fluid can go through, but can the dots? No, the dots cannot go through. Dots are the same. Cannot move through the membrane. So write that down. The liquid can. It can move through. That pink liquid, it definitely can move through. But the dots can't. We'll come back to this later. That's just the one I want you to kind of notice. Semi-permeable means some things can go through, but others can't. Okay, and your cells are just like this. Do your cells need to keep some things out? Absolutely. Yeah, some things don't belong in there. But do they need to bring things in? Yeah, you need more nutrients, more water. On the other side, what if everything could leave your cell? Would that be good for your cells? No, it would be a problem. But your cells have to get rid of things sometimes, right? You gotta take out the trash. If I came in and took your garbage out, would you get mad at me? No. What if I came and took your TV out? Or your computer? Or your refrigerator? You wouldn't like that, would you? That's a problem. You need that stuff. But the garbage, you can get rid of. Okay, so this is just a diagram to show how membranes are selectively some things move through, some things don't. Okay? All based on what your cell needs and what those molecules are. All right? So, we're going to do 2 things today. The first thing, I'm going to give you some time to work annotating. Can I borrow this real quick, Chloe? Annotating this. Okay, so I need you to start annotating where you're writing notes, underlining. There's times where it has a little multiple choice question, so check all the boxes that are true, do that. You're not graded on whether or not, you got them correct or not. I just want you to do it. Just do it, okay? And then it's got some lines where you respond. There's sometimes places where there'll be a question and there will be 2 answers, like it says, when the leaves of a plant wilt, there is not enough or too much water in each cell's central vacuole. So you got to circle it's too much or not enough. Okay, you got to make that decision. Just do your best, circle it based on what you read, and then move on. Okay, so I'm giving you about 30 minutes to do that. Because you guys, I can tell, need some time for that. If you don't have this, okay, what you're going to do is the next activity, which I'll explain in more detail in about half an hour, is going to be based on the membrane, all right, that's what we talked about. So I'm going to have you draw this diagram, label it, and then come up with at least 3 questions that could be answered based on the information we learned in the warm-up or on the paper right here. Okay? And I'm going to have you do that just on this piece of paper here. Draw the membrane nice, label it, take your time, don't go fast, too fast. and then write 3 questions. Okay? All right, so if you want to listen to music while you read and annotate, that's okay, as long as I see your focus. If you're on Instagram constantly, then I'll say the headphones aren't really working out for you today. Okay? All right, so let's all start reading, and I'll pass out these papers to anybody who doesn't have their book with them. Okay. No book? No book today, Lily? You get my message with you can start at the beginning. The best pages to do would be the page that has this, because we are going to be looking at that. So open it up, Jeremy. Keep going. Keep going. Keep holding. Back up. No, back up. Okay, no. There. What page is that? 469. That would be good to start on 469. Because we're going to be talking about it. You're going to be working on that later. Okay. Ooh, there we go. You will eventually, yeah. Yeah. Yes.
So right now we're also working on 469.
Yeah, I said 467, 469, I want you to start that. Alright. Good job. Appreciate a lot of you. Oh, you need a stapler? A lot of you guys have brought your books today, so that's good. Good on you.